Hi everyone, welcome to the channel. Today we will be continuing with lecture 4 for Indoor Environmental Quality chapter for LEED Green Associate Exam. We will cover all these credits in detail. Let's begin. Till now we have covered about 7 credits and 2 prerequisites in this chapter. There is 2 more, that is quality views and acoustic performance. This credit holds only one point, and the intent is to give building occupants a connection to the natural outdoor environment by providing quality views. Now let's look on to the requirements. One is achieve a direct line of sight to the outdoor through vision glazing for 75% of all regularly occupied floor areas. Then view glazing in the contributing area must provide a clear image of the exterior, not obstructed by fits, fibers, pattern glazing or any added tints that distort color balance. Additionally, 75% of all regularly occupied floor area must have at least two of the following four kinds of views. 1. Multiple line of sight to vision glazing in different direction at least 90 degrees apart. Then views that include at least two of the following: 1. Flora, fauna or sky, 2. Movement, and 3. Object at least 25 feet from the exterior of the glazing. And third, unobstructed views located within the distance of 3 times the head height of the vision glazing. And finally, views with a view factor of 3 or greater as defined in Windows and Offices, a study of office worker performance and the indoor environment. Include in the calculation any permanent interior obstructions. Movable furnitures and partitions may be excluded. Views into interior area may be used to meet up to 30% of the required area. The final credit in this category is acoustic performance. As same as the quality views, it only holds one point, and the intent is to provide workspaces and classrooms that promote occupants' well-being, productivity, and communication through effective acoustic design. Requirements. For all occupied spaces, meet the following requirements as applicable. For HVAC background noise, sound isolation, reverberation time, and sound reinforcement and masking. HVAC background noise. Achieve maximum background noise level from heating, ventilating, and air conditioning system per 2011 ASHRAE Handbook. HVAC Applications, Chapter 48, Table 1. Then AHRI Standards 885 2008 Table 15, or it can be a local equivalent. Then calculate or measure sound levels. For measurements, use sound level meter that conforms to ANSI S14 for type 1 precision or type 2, that is for general purpose sound measurement instrumentation, or it can be again a local equivalent. Then comply with design criteria for HVAC noise levels resulting from the sound transmission path listed in ASHRAE 2011 Application Handbook, Table 6, or a local equivalent. Other than the ambient noise, sound isolation is also a requirement for achieving acoustic quality. So here LEED suggests that to meet the composite sound transmission class, that is STCC rating listed in the given table or from the local building code, whichever is most written. So here in this table we can see the adjacency combinations and STCs. So here if a residence, that can be with a multifamily residence or hotel or motel room, and it adjacent to residence, hotel or motel room, the STC rating should be 55, and if it is come up with a common hallway or stairway, The STC rating should be 50. Then retail and retail it's 50. Then mechanical occupancy room or an occupied room, it should be 60. So the variation of STC's ratings can be seen from this table. This table actually depicts the minimum composite sound transmission class rating for the adjacent spaces. Reverberation time. It is another very important factor when it comes to an acoustical property of a room. Reverberation time is basically, it is a time required for the sound in a room to decay over a specific dynamic range, usually taken to be 60 dB when a source is suddenly interrupted. As the reflecting surfaces inside the room increases, the reverberation time also can increase and it can impact the quality of sound. It can become irritant. So basically it is the time required for the sound to fade away or decay in a closed space. Here in the table it shows the room types, application and the required reverberation time. So we need to achieve the reverberation time as per the table. The remaining list is given in the next page. Next is sound reinforcement and masking system. Sound reinforcement for all large conference rooms and auditorium seatings more than 50 persons. Evaluate whether the sound reinforcement and audiovisual playback capabilities are needed. If needed, the sound reinforcement system must meet the following criteria. Achieve a speech transmission index, that is STI, of at least 0.60 or common intelligibility scale, that is CIS rating of at least 0.77 at representative points within the area of coverage to provide acceptable intelligibility. So intelligibility is also another term when it connected to the acoustical property of an indoor space. So it is actually the understandability of a speech, sounds and words. So basically the clarity, deals with the clarity. And the next point is having minimum sound level of 70 dBA. Minimum sound level of 70 dBA, then must maintain a sound level coverage within plus or minus 3 dB at the 200 Hz octave band throughout the indoor space. Next is masking. So sound masking is the process of adding background noise to make speech less intelligible, thus reducing distractions, protecting speech and improving the comfort. Or more simply put, sound masking is noise used to cover other sound to make them harder to distinguish. Here, making system for project that use masking system, the design level must not exceed 48 dBA. Ensure that the loudspeaker coverage provide uniformity of plus or minus 2 dBA and that speech spectra are effectively masked. Well, today we have covered the remaining 2 credits in this category. Thus, we have completed the chapter regarding indoor environmental quality. Tomorrow we will start with the new chapter. Till then, bye.